Now we're going to bring down the 1, right? Are we done?
No.
We're not done. What do we need to do here?
Divide the 1.
Yes, divide by negative 1. Because we have an imaginary 1 in here, we cannot have a negative variable. We can only have a negative number. So now we're going to divide this by negative 1. So what is my x equal to?
0. Negative 1.
Negative 1. Because 1 divided by 1 is always 1. Okay, now we know our x, right? We can pick either one to plug this in and solve. Now I have a question. What's the easiest one to plug it into?
The 4.
This one right here, right? Because this one, there's no multiplication here. All we have to do is plug that number in. So now you're going to write this. Y equals x plus 3. Draw a line underneath it. Why do we draw a line underneath it? We draw a line underneath it because it's the original problem before any changes. Okay? So in our work, believe it or not, what happens a lot of times is sometimes the student won't write the same exact problem down. And then they go and solve, and they're like, wait a minute, I don't understand why it's not connecting, or how come it's not a solution, or whatever. So this is why you do this, so you can see this. So now we're going to go take this x, negative 1, and we're going to substitute it in. So y equals, our x is negative 1 plus 3. So what is y?
2.
2. Are we done?
No.
We have one more step. What do we need to do?
So I don't know.
Ordered pair.
Oh, yeah.
There's our ordered pair. Okay, we're going to go through it one more time. They're both equal to y, right? So we're going to write them side by side, and we're going to solve to get x by itself, okay? So we decided 3. Now, can we move the x over? Or can we move this 2x over?
Yeah.
In this case, it didn't matter. It didn't matter because we had x's on both sides and we had numbers on both sides. As long as we follow the rules, we're okay. We could take this problem, do the same exact thing, and start with the 4. It didn't matter because this problem is completely balanced. There's numbers on both sides and there's x's on both sides. So it didn't matter. We could have chosen whatever we wanted to. Okay? As long as we followed the steps. So we solved. We got x was equal to negative 1. And then we took this. Didn't matter the equations because they're both equal to y. We plugged in and substituted the negative 1 for the x, and we solved for the y. So now we have our ordered pair. Right? So let me give you a little tip. When you get to your test on Thursday, do these first. These are the easiest ones. Okay? Equal to equal. Put them side by side. Isolate. Solve for the variable. Plug it into the other equation. Okay? How do I start this one? No.
No?
No, because they're not equal to y, are they?
No.
They'll be fixed.
Very good. Why? Why did you choose x?
Well, are we done with the first one?
Yes, we're done. This one's finished.
What about the y equals 2x plus 4? Did we just leave that alone?
Yeah, because we already solved for y. Ultimately, we tried to figure the ordered pair. We got it. Could we go do it? Yeah, but it's unnecessary. Okay, so x is by itself, right? It doesn't matter which one we choose. We're going to be able to isolate and get the problem by itself, okay? So we want to take one of these equations and get the x by itself, okay? We can pick either one. It doesn't matter. Which one do you guys want to pick?
The x plus 3y.
This one? Okay, so write that. X plus 3y equals 12. Draw a line, because that's going to be the original problem. Oh, no, I'm sorry. There's no substitution. We don't need a line. Got ahead of myself. Okay, we want x by itself, right? So how do I get x by itself?
Minus or negative?
Right. Cancel this out. Now I have a question. Can we do anything with this?
Just
Can we?
subtract.
Can we subtract them? Are they like each other? The answer is no, because that's a y, right? With that y being there, these are not like each other. We have to leave this alone. Okay, so how we're going to write this is x equals 12 minus 3y. We cannot combine any of this. These are not like each other. Okay, now that we did that, we're going to take all that information, and I'm going to give you a little tip that I do. You don't have to do it, but it helps me. Okay? I put this in parentheses. Guess why I do that? Because I know I got to take all this information and plug it into the other equation. So we started with this one, right? Now we're going to go to this one. Write this. x plus 2y equals 8. Draw a line underneath it. Yes?
This is just a random question. What class do you think that is the most easiest to teach? Like, are your classes like? Because last time I stepped in, like,
It all depends. It all depends.
like
Honestly,
the
it all
other day I stepped in, you guys were like having like a whole fight back here.
it all depends on the class. But I'm recording right now.
Uh,
Okay. So x, we're saying x is equal to all this stuff, right? So we're going to take this information and we're going to enter it in here. Now, luckily for us, this one's kind of easy, right? We're going to take this information and we're going to write it first. So write 12 minus 3y and put it in parentheses. Okay? Now, we just put in for x, right? We substituted for x. We're going to write the rest of the problem. Someone tell me what's left in the problem. I wrote the x.
2y equals.
Very good. Now we're ready to solve the problem, aren't we? Now, I'm going to give you a little tip here. Watch this. Do we really need the parentheses here?
No.
We don't, because it's the first set of numbers, okay? Typically, like if it were going in for y, we'd have to enter it in parentheses because we'd have distributive property. Normally, you don't have the first number in parentheses, okay? So we can actually get rid of the parentheses. We're okay here because we have an operation here. Now, someone tell me what I need to do from here.
Wait, why did you take out the
Add the y.
Because they don't matter. We're not minusing it by, we're not multiplying it by anything because there's nothing in front of the parentheses.
Don't you gotta add the y together?
Very good. What do we call that? You're close.
Substitution?
How about
Navarro, please come to the front office. Matthew Navarro, please come to the front office.
combine like terms?
Oh yeah, combine them.
Okay. Now, what are similar to each other here?
The 12 and the 8? No, the 12 and the 2?
Well, we can't do anything with the equal sign. We're only focused on what's on both sides of the equal sign. That's just a number. There's nothing we need to do to that. That one's a number. Aren't those y's?
Yeah.
So we can simplify these y's, right?
Yeah.
So if I have negative 3y plus 2y, what's my answer?
1, negative 1, 1.
Right, negative y. Bring down the 12, bring down the 8. Very good, very, very good. Okay, now we got to get y by itself, right? So we got to move the 12 over, right? So we're going to write minus 12 and minus 12. It's going to cancel this out. Where negative y equals negative 4, correct? 12 minus 8. Now, are we done? Why aren't we done?
Because the y's negative.
Yes, we can never have a negative variable. Once again, you see it on there, easy merit, and it's graphing. There's no such thing. This doesn't exist. Just like, can you have a negative 0?
No.
No, there's no such thing. Can you have a positive 0?
No, because
No,
you can't.
0 is 0.
0.
It's not positive, it's not negative, it's nothing at the end of the day.
Neutral.
But writing it, you're never going to see this. So if you have an answer that shows a negative y and you're trying to solve for y, you know it can't be that one.
So there's not an answer that can be like negative 1y, right? That doesn't make sense.
No, it can be, all we're concerned about is the variable by itself, okay? If the variable by itself and it's equal to a number, it can't be negative. So, this is multiplication. So we have to divide this by negative 1, divide this by negative 1. So y equals what? 4, right? Because negative 4 divided by negative 1 is positive 4. Negative by a negative. Now I have a question. Are we done?
No.
No, because we've only done the y at this point, right? Okay, so let's talk about this for a minute. But we use this equation, right? We use the 2y, we entered this in, and we solve for y, right? So that means after using this one, we're going back to this one. So write this again. X plus 3y equals 12. Draw a line underneath it. Okay, we're going to substitute the 4 in there, okay? So it's going to be x plus 3. How do I put the 4 in there? Yes? This one's kind of neat how it works out. So what is 3 times 4?
12.
Okay, got to get the x by itself, right? I'm going to subtract 12. I'm going to subtract 12. What just happened here? Is that a real thing?
No.
It is, because what's origin? Origin on a number line.
Oh, yeah.
So we have a coordinate, right? Our x would be 0, and our y would be 4. So our point would be right there. So now wherever last part are 0 and 4, we're done. So yes, it can be 0. And the whole idea is, it's a coordinate, right? It's an x and it's y on a graph. Okay, what about the next one? Look at C. What's the easiest way for me to start that problem, you think?
The y.
Is the y by itself?
No, the
The x is by itself. So we're going to take that first one and do the same thing. So write x plus 2y equals negative 1. Now that one's pretty easy to solve, right? Because the x is already by itself. Are you guys done? Are you done? Okay, let me get you here, and then we'll get back up here. So write that. Right? You're good? Do you have this part down?
That last one.
Okay, go for it. We'll wait for you. Okay, so this first one, we have an x by itself, right? So we want to choose the equation that's easiest to get a variable by itself, because we're going to need to substitute it at the end of the day. So we did the same thing on this, right? But these were both x's. It really didn't matter which one we chose. It was just going to be a matter whether this was negative 2y or was negative 3y. It really didn't matter, okay? This one kind of matters, because it's x plus 2y, and then the second equation is 4x minus 4y, right? So we have numbers in front of those variables, which would mean we would need to divide, okay? So that's why we choose the first one, because all we have to do is subtract the 2y from both sides. So let's go ahead and do that. Minus 2y. Cancel it out, draw a line. Now, can we combine these?
Yeah.
We can? Look
No,
up.
we can't.
No, because they're not the same, right? That was a trick. X equals negative 2y, negative 1. Now, put this in parentheses. Okay? Now we just dealt with this one, now we got to go deal with this one. So rewrite it. 4x minus 4y equals 20. Draw a line. We know what x is, right? So we're going to insert all this inside the parentheses with the x. So we're going to have 4, parentheses, we're going to write this information. Negative 2y, negative 1, and then minus 4y equals 20. Did the parentheses matter this time? They did, because it wasn't the first thing, right? We have 4 multiplied by x. So that's why we have to do that. Okay, someone give me a vocab word. How do we solve this? How do we get it out of the parentheses? What do we call that?
combine like that.
Keep going. We can't combine them yet because we have to multiply.
So-
What is that? What is that? Well, substitution is what we're doing.
Like that with both.
What's that called?
Um,
Starts with a D.
determinate.
I love it. I want to start
Is
using
it
that
on
one.
here? Is it on one of these graphs over here?
It is.
Oh,
How about distributive?
Oh.
Right? Because we have to take that 4 and we have to distribute it across the problem, right? We have to take it, multiply it by this, and take it and multiply it by this, right? So we're going to go ahead and do that. What's 4 times negative 2y?
8,
Yes, negative 8y. And what is 4 times negative 1?
4,
Yep, whoops. Now, our brain plays a trick on us. Look at this problem here. Do those 4 y's matter?
yeah.
They do. They're both negative, right? So we can simplify those, combine like terms. So we're going to add these together. Whoa, did I write that out wrong?
Yeah.
No, I didn't. Yes, I did. I forgot this right here. 8, negative 8y, negative 4, negative 4y by itself. Okay. However, look what happens there. Can we do anything with those?
Yeah.
Well, that's a 4 by itself, and that's negative 4y, right? So can't we combine these two?
Yes.
What's 8 and 4? 8 and 4 is 12. We're going to subtract 4 equals 20, right? Then this is going to work out. So we're going to add 4 to both sides. This is going to cancel out. So we're negative 12y equals 24. How do I solve that? I got to get the y by itself, right? So what do?
Divide
Yep, divide by what?
by negative 12.
Very good. And what is 24 divided by negative 12?
Negative 2.
Yep, negative 2 equals. So we know our y, right? So this is the problem that we worked on, right? We now got our y by itself. So we're going to go back into this problem and plug it in and solve for it. So write that. X plus 2y equals -1. Draw a line. Then we're going to solve it. X plus 2. What goes inside the parentheses?
-2.
-2. And what is 2 times -2?
-4.
Okay? Now we're going to add 4 to both sides. X equals 3, right? Okay, don't we have our ordered pairs? We're done with that problem. Any questions on that? So notice C was a little bit similar to B, right? The only thing that was different is there was a clear-cut one to pick, right? We couldn't really use the second one. I mean, we could have, and we could have followed the rules, but it would have been more math for us to do it. So what about D? What do we do on D? This would have been example B from Monday. What do I do with that one?
Wait, what?
Remember, we had 3 examples. The first example was y equals y, right? We make them next to each other. Our second example was 1 equal to y in some other problem. We work with the y first, right? So we're going to work with that y. We already know what this is. We're going to select this one, and we're going to insert it into here.
Wait,
Okay?
Mr. So can you go back to problem B where, okay, so you said A starts off by side, right? So what would B, how would B start off?
So this one we want to start off by getting a variable by itself. But look, yes, yes, pass it in the back. Aren't both these variables equal to itself? They are. So did it really matter which one we picked? No. But the rule typically is you have 3 ways to solve. Y equals y, side by side. 2 sets of equations. If one is equal to y, use that one, start with that one. Nothing, there's no clear cut. You want to take one that the variable is by itself, or whichever one is easier to solve and get the variable by itself. Okay? So notice you have choices. As long as you're following rules, you're going to get the right answers. So we're going to start with this, and we're going to insert it into this. Okay? So write this. X equals 2y plus 6. Draw a line underneath it. Now, what's interesting, we're going to put this one in parentheses, right? But isn't this one first? Actually, it's not. It's not first, because there's 2, right?
Wait, you said X equals 2y plus 6?
Yes. And all I did was take the second one, because we're leaving this one alone. So we're going to go ahead and enter all this information right here into here. So X equals 2, parentheses, minus 3x, plus 4, parentheses, plus 6. So all I did was take this information and plug it into the equation. Right? You writing this down? Okay, now we have distributive property again, right? Because we have to multiply to get out of these parentheses. So where x equals negative 6x, and then 2 and 8, or I give you the answer, 2 and 4, which is 8, and 6. Now what can we do in this problem? Is there anything we can combine together?
8 and 6.
The 8 and 6. Very good. So we're 14, right? We're 14 plus negative 6x equals y. X, excuse me. I don't know why I did that. So, how are we going to solve this problem? It kind of tells us, right?
Yeah.
We need x's to one side, and we need numbers to another. So we're going to add 6x to both sides, okay? Plus 6x, plus 6x. What's 6x plus x? There's a 1 in front of here, right?
7.
Yeah. So 7x equals 14. Divide by 7, divide by 7. X equals 2. Now I have a question. So we worked on this equation right here, right?
Was that X, right? Was that X?
Yeah, that looked kind of dicey there. So we worked on this equation. Where do I go put this x now?
No order pairs.
Well, I have one of the order pairs, right? But I still have to solve for y. What do I do with this x? Which one do I use and why?
You plug it in and you just right? You plug it into the.
Yeah, kind of. But which one am I going to choose now? Which one am I going to put in and why? Does anyone know?
3x,
Very good. Why was it 3x?
because we're trying to find y.
Right. We just did 2y. So we did this one. We got x by itself, so we always go plug it into the next one. If we plugged it into the same one, we wouldn't get the answer right. Okay? So when you work on one, go to the next one. Okay? So we're going to do the same thing. Y equals negative 3x plus 4. Draw a line underneath it. And we're going to go enter x for 2. Okay? So y equals negative 3, 2, plus 4. So now solving that, we can figure out what the y is. So this becomes negative 6 plus 4 equals y, which is y equals what? Oops. Negative 2. Right? So there's my x, there's my y, I'm done. I'm 2, negative 2, there's my ordered pair. I'm finished. Okay, let's talk about these. This is what your test is on. You're going to have some that are y equals y. You're going to have some like this. You're going to have some that are equal to y. Okay? You need to know which 3 ways to go and solve those. You're trying to solve for the ordered pair and knowing the steps. So I have a question. This, you put your name on, you're going to turn it in. Okay? This is your do now, separate sheet of paper. Is not this problem super, 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 super easy? Because it's halfway done for you, right? You already know what x is. If you know what x is, you're going to plug it in the next one and solve for it. Isn't that real easy to solve? Yes. Let's talk about this one. How am I going to start this one? Do we have a variable by itself? Yeah. So we're going to use that. We're going to input it into here, substitute it, and solve. What about this one right here? This one's similar to this one. I wrote the same exact problem. Look at that. Boy, that was a gift, huh?
Oh, wow.
I wrote the same exact problem. And you know what's the sad thing? The other class didn't even catch it. That's sad.
So basically, number 3 is done for us. And
Yeah,
number 1
right?
is very easy.
Okay, let's talk about this one right here. Can we simplify this problem before we do anything?
Yeah.
We can, right? There's y's, right? We can simplify that. This one's a little more challenging. You want to get a variable by itself and solve for it, okay? Okay, make it happen. Any questions? Is there any that I need to go over again? Do you see the pattern? We're isolating variables, we're substituting information when it comes to 2 equations to solve for variables, okay? Okay, so you want to turn this in, you want to do your do now, and then when you're done with your do now, you want to be getting that worksheet done that was on Monday. If you need it, it's in the back, it was on the back side of the notes.
Oh, yeah.